Okay. We are in day 4 of probability. Let's see. Okay. And we're talking about probabilities that have effect on one another. So if they don't have any effect on each other, they're what's called independent. And then if one does affect the other, that's a dependent probability. So let's start with just an example. Sam has a bag containing 15 Skittles, and they're 4 red, 3 green, 5 yellow, and 3 orange. What is the probability you shake the bag and a red Skittle comes out? Well, there's 4 red out of 15 Skittles. So that's your probability. I would prefer you get in the habit of making a fraction and a percent. But we'll just leave them as fractions from now. I prefer the most reduced fractions, preferably. But if we don't, we don't. It says, suppose you shake a bag and out comes a yellow Skittle. So we're resetting the bag. We still have 15 Skittles now. So what's the probability? You shake the bag, out comes a yellow Skittle. Now, what is the probability you see a red Skittle? So we want to know what the probability is that we get a red Skittle, given that we just had a yellow. So these are a little bit different. I still have a probability of red of 4, but a yellow one just came out, so now it's 14. You've done this before in middle school, but you didn't write it or notate it or were conscious about it like that. You were just like, oh, a yellow one happened, now I have 14. So we're saying, what's the probability to get a red given that yellow just came out? This little line means given that, okay? Notice in our second example, the probability of receiving a red Skittle depended on the event of receiving a yellow. So I'm going to show you some examples, and you're going to decide whether the following events are independent or dependent of each other. If I roll a die and I toss a coin, do they have an effect on one another? No, those are independent probabilities. I take a marble out of a bag, and then I take a second marble out of a bag. Well, nothing affected the first one, so it's independent. And then I took a second marble out of the bag. Well, that was dependent upon whatever came out of the first. Okay. I choose a person from a group of 50 people. Nothing was affecting that. And then I choose another person. Well, that's dependent on the kid I chose first. It says I draw it from a deck of cards and I put it back. Well, nothing affected my first draw. And nothing's going to affect my second draw. Draw a card again from the same deck because I put the original one back. Okay. So if they don't have an effect on one another, they're independent. On the back, it says, pictured right is Haley's toy box. You choose 3 objects at random without putting them back in. You're going to choose a heart, a tree, an umbrella. What is the probability that I get a heart and then a tree and then an umbrella? Okay, I guess I got to put an H. So the probability I get a heart is 1 out of 6. The probability I get a tree is 1 out of 5 because I took a heart. And what's the probability I get an umbrella? 1 out of, now I have remaining 4 objects. So that's going to be 1 out of 120. Okay. Now, you wouldn't really write it like this. Really what is happening is saying, what's the probability I get a heart? And then what's the probability I get a tree, given that I just got a heart? And what's the probability I get a umbrella, given that I just got a tree, given that I just got a heart? It's really what you're doing. You do not have to write it like this, okay? But understand, we're not putting them back, so it's not going to be 1, 6, 1, 6, 1, 6. This one says, what if I do put all the objects back? This is called replacement. So what's the same thing? What's the probability I get a heart, a tree, and an umbrella, given that I put them all back so that there's 6 every time? Okay, it's going to be a lot different. So let's compare these. It's hard to compare these. Well, 1 divided by 120 is to the right, 0.83%, the likelihood this will happen. And when I put them back, you're lowering your percent to 0.46. So you're cutting that probability in half of getting a heart, a tree, and an umbrella. What if none of the objects are a heart? So when we say it's not a heart, it's its complement. A complement is not what it's talking about. So getting a heart is 1/6. So not getting a heart would be 5/6, or its complement. That little c means complement. Okay. So it's showing if A and B are independent events, probability of A, and this should really be and then B, not at the same time, but A and then B, you multiply them. If A and B are dependent events, you multiply them still, but you have to realize, be careful, probability of B happening given that A happened. Okay, this is just notation. Let's try our last example. It says Lee has 18 black socks and 12 white. Every morning he chooses one sock at random. After he's pulled that one sock out, then he chooses another sock at random and wears them. So what's the probability he chooses a white sock and then a white sock, given that a white sock just happened? Well, there's 12 white socks out of 30, and then 11 white socks out of 29. Okay, so 12 times 11 is 132 over 30 times 29, which is 870. When I divide 132 by 870, I get about 15%. So there's 15% chance that you get a pair of white socks. Okay, let's try it with a black and a black. So what's the probability I get a black sock and then I get a black sock given that I just got a black sock? Well, there's 18 out of 30 black socks. And then if I already chose a black sock, then that leaves me with 17 black socks out of 29. You know that's 870. $306. So what's 306 divided by 870? That's about 35%. Okay. CU. What's the probability I get a white sock and then a black sock given that I just got a white sock? So 12 out of 30, 18 out of 29. You know that's 870. 12 times 18 is 216. When we divide that, that's about 25%. And what's the probability I get a black sock and then a white sock given that I just got a black sock? So a black sock is 18 out of 30, and then white is 12 out of 29. That's about 25%. So white then black, black then white, they're both 25%. So I have all my possibilities. A white and then a white sock, a black and then a black sock, a white then black sock, and then a black and then white sock. Those are all your possibilities. It should add up to 100%. 25 is 50, 65. Yep. It says, therefore, what's the probability that he gets a pair? Well, what is considered a pair? A pair is a white and a white, or the pair is a black and a black. Or is more, you're going to add them. So what was probability? It was white and then white, 15%. Or is more, you add. And what's the probability it's a black and a black? 35. So it's 50%. It says, what's the probability the socks are a mismatch? Well, what's considered a mismatch? A mismatch is a white and a black, or it's a black and a white. So it is 25%, or is more, you add 25%, 50%. Okay, so that is independent and dependent probabilities. You've technically done this before. You've done this before. You've done this before. You just didn't notate it quite as sophisticated or mathematically mature as notating it like this, okay? So it's nothing too new. We have one lesson left. Make sure you're caught up on all your notes. And we're not going to do probably all the homework that's in the book if you were in the if we're in hybrid school right now. So make sure you look at the attachments for what your homework is.